Dear teachers, Assalamu alaikum. I'm Hani Ad-Dali. Again, I'm here to introduce the Qatar Astronomy Olympiad for school in its ninth edition. This year, the theme will be about the Earth and its size relative to the Sun. In the beginning, let me introduce the Sun itself. As you know, that the sun is, and our objectives for this Olympiad are almost three: to let students learn how to observe the sun safely. Second is monitoring sunspots and comparing their sizes to our planet's size. And we want to simulate the expected scientific observations of the solar cycle with our calculations or with our study. Now, if we want to talk about the sun, as you know, the sun is the closest star to Earth. Its mass is almost 333,000 times, and it has been living for 4.6 billion years now. It is made of hydrogen fused to helium, and it does this 600 million tons per second. Okay, the most important layer we observe on the sun is the photosphere, which is the yellow color. This photosphere is the highest and the upper layer of the sun. We are not going to go beneath that, maybe. But the most important, why is it important? Because we can see sunspots on this photosphere, as well as sometimes Mercury transit and Venus transit. We are going to study the behavior or the size of some large sunspots. Now, as you know, that the sun is rotating, and how could we know that it rotates? Due to the motion of the sunspots on the face of the sun itself. They appear moving, and this motion is relative and has something called differential rotation. Differential rotation means that some the sun, because it is rotating, because it is not a rigid body, so it rotates at the equator faster than on the poles. That makes the magnetic field lines, these lines, okay, they rotate as well faster in on the equator. Beneath, actually, they are rotating. All magnetic field lines are not visible. They are beneath the photosphere, so we don't see them. For that, as the sun is rotating, the sun forces them to rotate to with it, and with time, in progress time, the magnetic field lines get tight, and this tightness, it forces them to float to the photosphere and penetrate the photosphere. It's just like that. Here, the layer below the photosphere is called the convection layer, where the heat is coming up and going down. It carries the heat up. It's just like boiling water. So when the magnetic field lines are penetrating the photosphere, they don't allow the convection layer to carry the heat up. So they are not allowed to go through the photosphere. So from above, we see that this patch and this patch of the photosphere are darker because they are cooler. They are cooler because they are not allowed. They have not been not allowed to take the heat up. That's why we see what is called the sunspots. The magnetic field lines usually go out or penetrate the photosphere in 2 points or in two sunspots. You see, it's just like that. Sometimes we can see two sunspots, sometimes we can see one sunspot. It depends on this magnetic field line. Uh, in 2018, 2019, 2017, and those 4 5 years, the sun was so calm that it's called solar minimum. Solar minimum means no sunspots appear on the disk of the sun. While we are now in 24, 25 will be the solar maximum, and we will be seeing more and more sunspots. So the appearance of sunspots is the indication of the solar activity or the solar cycle. The solar cycle usually takes 11 years. Out of them, half of them is solar minimum, and the other half of them is solar maximum. It means that our solar cycle, which is numbered as 25, started in 2020, and now it will continue till it 2030 or 2031. So in these 11 years, we will be having something now, sunspots. Then in the last 5 years, we will be having something like that, which is solar minimum. Okay, now the motion of the the sunspots, as we said it is differential. So the speed, the rotational period on the equator of the sun usually takes 25 days, while in upper latitudes it is increasing to 26, 28, 40, and it goes even slower at very high latitudes, north and south. Okay, in the beginning of the solar cycle, we said that the very first appearance of sunspots occurred in 2020. So the first sunspot appeared in that period. Usually they appear in high latitudes away from the equator. With the progress of the solar cycle, more sunspots will be appearing, and they are coming and appearing closer to the equator. And with the maximum, around the maximum of the peak of the solar cycle, we are talking about 25, 24, 25, 26. Most of the sunspots appear very close to the equator. This motion from higher latitudes to lower latitudes, with different, of course, sunspots all over the solar cycle, they were grown as what's called the Maunder butterfly. So these sunspots, usually this is one solar cycle. One solar cycle means 11 years. So we are talking here about 1910, 1920, 1930, and so on. So if you take one solar cycle, let's say from here to here, okay, so see, in the beginning of the solar cycle, most of the sunspots were appearing in the upper latitude. Then with the progress of the time, okay, when it became maximum, most of the sunspots appeared near or closer to the equator. And this again reoccurred in different solar cycles. Now we are in the solar cycle 25, which started in 2020 and will finish almost in 2031. Okay, these cycles have been counted for the last 400 years almost. That's why we have this 25th cycle now. In 2000 to 2010, it was the cycle 24, and 24 was just like that. What does this mean? Doesn't it, it means the number of sunspots appearing on the disk of the sun in some particular period. So here it is almost between 120, 110 or 120 for the cycle 24. Now, scientists are expecting that cycle 25 will resemble the cycle 24, and what this is one of our project. Is it going to do this, or it will exceed it, or it will be less than that? We will study that, and we will write our results. So this is the fit of the results, or expected results for the cycle 25, and the peak will be in July 25. So this is the cycle 24. They are expecting that cycle 24, 25 will resemble cycle 24. Now, the sun is sending its as well the charged particles all over the universe. Let's say the universe around the sun, and they are hitting Earth, but Earth is protected by its magnetic field. This magnetic field lines here, they don't allow the particles, the electric particles, charged particles, to penetrate directly. So they follow the magnetic field lines, and they might penetrate when the sun is active from high latitudes in the atmosphere, almost 400 kilometers above the Earth, in south and north hemispheres, to show us something called the aurora. The aurora is amazing phenomena, and can be seen, as I said, in higher latitude. But sometimes when the solar activity or the sun is active enough, this might seen or be visible even in lower latitudes. The last 10 days ago, we could see the aurora from Saudi Arabia, as it is mentioned in one of the newspapers. The people could see aurora. Of course, this is the photo they recorded for this aurora, and this is not rare. Actually, our history, the Arabian history, has recorded that aurora was seen even in Yemen. Yemen is 15 latitude, so very low, near equator, because at that time sunspots were covering almost one third of this disk of the sun. So it was a huge activity of the sun that occurred almost 300 years ago. Anyway, on the sun's disk, the sunspots themselves are named, or are given numbers as active regions, AR. And now this for this sunspots, for this sunspot 3030, actually it was 13,030, but they removed the 10,000 and they kept the 4 digits. So it became AR 3030. And now we are still counting, now almost 50 something. Now, even if the sunspot is single, again, it is given a number. Sometimes the sunspots are appearing to the right. This is the eastern limb, and this is the western limb. The sunspot can appear anywhere, anytime. So it's not necessary that the sunspot here in this side should be older than the sunspot here. See here, 3036, while this one is 3031. This appeared before this, but still this one is on the west limb. It means that it has just appeared. Okay, methods to see or to observe the sunspots must be safe methods, and we have 4 methods. This is called telescope, solar telescope. It is equipped with the H alpha filter, and it is already very expensive telescopes, and might show you something other than the photosphere, even the other layers of the upper layers of the sun. The second method is a projection method, which we are going to use by projecting the image of the sun through the eyepiece. Okay, here the objective, this is the eyepiece, and we will project project it on a screen so you can see the sunspot. The third one is using a filter to filter the sunlight before entering the telescope. Then you can see the sun safely. But I usually advise don't stay long looking at the sun in this method. This solar or eclipse shades are usually used for solar eclipse, because they will show us the sun is eclipsed. Usually, they don't allow us to see the sunspots because sunspots are small, unless if the sunspots are so huge. Okay, now I'm going to go through these three projects, and the very first project will be the promoting the sun and the solar cycle 25 in schools. So what we want is exactly what we did last year. We promoted this cycle and the sunspots among our students. For example, we asked to show the students the sunspots through telescope, and to tell them about the solar cycle and the importance of this cycle and how to observe the sun safely. The subject of the project is here. This the sun. This a telescope. These are the students. Okay, I can see everything. This is very clear. And the subject here, I have students, I have a lecturer, and I have the theme, the subject of the lecture. Okay, so what we want from you, we want you to do two things. You have to target 300 students with lectures and solar observation, sun observation for the sunspots. You have to take the students out to show them by projection method the sunspots, as well as to tell them about the sun itself by lectures and by live observation. Now, you at least I want 300 students from each school. For those schools who don't have or those don't have this number of students, it's okay. They can tell me that our students are less than that, and we could do this for those and those. Okay, what you are supposed to do, you have to tell me that this event is telescopic observation, write the date and the number of students. The number of students is very important. Round it to 5. It's okay. If they are 22, make them 20. If they are 53, make them 55, and so on, and so on. So on. Please, if you are giving a lecture or a talk, write the date and the number of students. If you are repeating this lecture or repeating this observational telescopic observation for other students, please write in the this table how many times you did. You might do other activities, such as having a guest to lecture or to talk about this phenomena, or you might have some activities like hands-on. Please write them here in the table. This will allow you to get more marks. Now you have to submit 8 photos, half of them for the lectures, half of them for the telescopic observations. They should be high resolution photos. They should be attached separately. Don't attach them inside a Word or PDF files. Okay. Now, this project actually will be the key to pursue in the Olympiad. I want the results of these projects as soon as possible. Of course, after the vacation, you will start doing this project, and the students will attend the training session for telescopes to how to carry out this this project. Okay, see, from last year activities, we have this school, Berla School, have brought a telescope equipped with the solar filter, and the students in the daytime are looking at the sun. Here, girls, students, they are attending a lecture, and there's a lecturer, and this is the topic. This is, I don't need the faces of the girls. I need the topic itself. Here in Lebanese school, we have the teacher, we have the solar filter, and we have the students. Here in one of the boys' school, we have the lecturer, we have the audience, but I need to see the the screen showing that he is talking about the sun, because nothing proves that this is talking about the sun or our Olympiad. But for this school, Ayman, they have written their name here, Ayman, and they projected, this is the telescope. I would prefer that the telescope appears here, okay, with the students, and this is the projection of the solar disk on the board here, whiteboard. So, and this is the sunspot. These are the photos I prefer that you submit. Please take care of photos. Take as many as photos you like, but at the end, submit me the best photos. Here, a panorama of the photos of activities, different activities from different schools of the last year's Olympiad 2024. Perfect. I love it. Now, last year, we targeted 69 schools with more than 55 telescopes. Some actually, some schools couldn't have telescope. They borrowed telescope. Okay, some students themselves, they have telescopes. They can bring the telescope to the school. Some schools took the telescope either from me, from Doctor, from Darut Taqweem, Calendar House, or even from other schools. So you can manage yourselves. Last year we targeted, as I said, 10,000 students. This year we are targeting 20,000 students. Why? Because we have more than 100 schools participating. Last year it was only 69. Now we have almost 116. The second project, now what this is, the second project is talking about the theme of the Olympiad, the Earth and its size relative to sun spots. So we are going to compare between the size of the Earth to the size of the sunspot. The sunspot is always larger than the Earth, even the very small ones, they are larger than the Earth. So imagine that we are going to calculate the area of the sunspot and calculate the area of the Earth here. We will compare these two areas. This is our project. So what we are going to do, to go back to spaceweather.com. It is free online software. Actually, it's not software, it is a website. So when you enter the date here and ask it for view, it will show you the disk or the photo of the sun on that day. You can go back 24 years till 2001. Okay, so and when you use this table here, this screen will appear after that. So we will be using this upper timetable or date table. So you will go. I will give you two sunspots actually. When you just click on this photo, it will be enlarged and it will be full screen. What I mean by full screen? Full screen, you will be seeing a full circle, a full disk. But of course, I don't want the full disk from up and down. I want the full disk from right and left, because I need to measure the diameter of the sun as it appears here on the screen. So I must bring my ruler. Okay, I don't know if you can see me here. And here, this is, okay, this is a ruler. And I'll put on the screen when I put in the screen, I can measure by centimeters and millimeters. At the same moment, I have to measure the diameter of the sunspot. Can you see the sunspots? I just took a screenshot. I enlarged it, expanded the photo till it touched the two sides of the screen. I added a circle, okay, around the sunspots, the targeted sunspot, and I imagined or I suggested that this is the size or this is the okay diameter of the sunspot. So what you are going to do is to measure the distance or the diameter. Okay. Now, if you imagine that the sun is the diameter of the sun is 109 centimeters, it means the Earth is 1 centimeter. It means that we can add 109 Earths here on the diameter of the sun. Now you go and you are going to measure. You will not get 109 because your screen is not 109 centimeters. It might give you something like mine. See what I got in my. I took this example. I took this sunspot here, 3799. The date was 26 August 24. So I gave you two sunspots. You have to work on these two sunspots. Okay. Um, don't be concerned about this thing already given you and give all the teams. So you have to go to these dates and do the same calculations here. My calculation, I found that the diameter of the sun is 52 centimeters. Okay. Then I found that the diameter of the sunspot here, diameter of the sunspot, 1.8 centimeter. It means that the radius of the sunspot is half of that, and the area of the sunspot is 2.54 centimeters square centimeter. Now, I'll go back to the diameter of the sun on the screen, okay, which is 52. 52, I'll divide by 109. You remember 109 Earths if it will fit on the disk of the sun. So by dividing these two numbers, I will get 48 centimeters, which is the diameter of the Earth as seen on the screen. As if I bring this 48 centimeters, I need 109 of it. I will fit on the screen. So the radius will be 0.24. The area of Earth will be 0.80. Now, by dividing the area of the sunspot on the area of the Earth, the small globe, I'll get how many Earths this sunspot will include in or engulf. Okay, and you have to do this for both. Now, one tricky thing. Okay, these are you will make as we said, you will make this board, 1 meter board. You will print out. You will make a zoom in for the sunspot and put the real Earth. If it is 14 Earths, so this Earth will be one Earth, and you have to show me this zoomed square. And you have to write the name and the title, your school name, and so on. So everything is already given in the literature. Go back to the sun. I use this grid to determine exact position of the diameter I'm going to measure, because when I drew this line, it was not correct. So I brought this. So see this grid when I hold it from the corner, okay, it will be transparent, and when it's transparent, I can see where is the exact diameter. So maybe like this. Okay, so look, see the diameter, my line, my blue line is below. I found it below. So you have to determine exact positions for measuring the diameter. Okay, so this is the second and the last project will be talking about this is for only for secondary schools. Okay, your team must be either secondary or middle school. You will take the readings from April to January, April 2020 to January 2025. You have to go back to spaceweather.com and take these dates. Okay, exact dates. You will go to this date, 1st of April. You will find one sunspot, this one sunspot. Go to June, you will find this sunspot number. So it is 65 minus 59 means 6. The next date, 74 minus 65, 9. And these numbers will be increasing with time. You see, you will be writing this and you will suggest in new dates, future dates, and copy these results so that when you make the drawing, okay, in the Excel, it will give you this shape. Okay, exactly. The right side, left side shape is exactly copy on the right shape. You will take this and compare it to the expected values of 24. So scientists are expecting this yellow, and our results here, when we draw it on Excel, I got this shape. Now I hold it from corner, and I'll just match it from right and left. I mean x-axis. Y-axis, I am going to compare. So I found by my results here, these are suggested, these are virtual results, that my results are higher than the expected results. I will write here, I will answer, choose the answer, yes or no, that the anticipated values of the 25th cycle is more or less. You will write this answer, and you will answer another question, because because we are not finished with the solar cycle. It will finish in July, but we stopped in January, so we still have 6 months. So with these 6 months, are you expecting to be the peak, to peak more or not? You need to give me the answer here in English, okay, and submit this diagram. You will make it in on board, half-meter board, and you will submit it in the exhibition at the end of the competition. Okay, so this is our these are our Olympiad projects. I hope that you can fulfill them, and explain them to your students. Please, any questions, just go and call me or send me on the WhatsApp. Thank you so much. Salam.